Compañeros, welcome to the SQL Data Partners podcast, the podcast dedicated to SQL Server related topics, which is designed to help you become familiar with what's out there, how you might use those features or ideas on how you might apply them in your environments. I am Carlos L. Chacon.
And I am Steve Stedman. We are two data professionals trying to help others get a better handle on their database environments, either through this podcast, our training, or our consulting practice. Thanks for joining us on the SQL Trail. Welcome to the show.
SQL Data Partners.
Compañeros, welcome to episode 103. Thanks for tuning again to another great episode.
Yeah, so this episode is on cache plans and plan reuse, which is one of my favorite topics in SQL Server.
Yeah.
I know I've had a lot of lively debates over the years around this.
Yeah, that's right. Because I think it's one of those things where you from a performance perspective, you kind of, so indexing and some of the other objects, and then you got to figure out, kind of get into the internals, if you will, of how SQL Server works. Yep. And yeah, it can be a bit confusing a little.
And this topic came to us from James Youkhanis, and he suggested that we talk about plan cache and plan reuse. So we want to thank him for that suggestion.
Yeah, we apologize. He suggested this. Gosh, I'm embarrassed to say how long ago it's been. But it was kind of during a time where we had a slew of interviews kind of lined up, kind of got pushed to the back burner. So we're glad to finally circle back around to it. We have a couple of shout outs this episode.
Yes. So one shout out came from SQL Gumbo on Twitter, and this was in regard to one shout out came from SQL Gumbo on Twitter, and this was in regard to a post that I had tweeted about Database Health Monitor, and he came back and said, "And why am I building these tools of mine?" I guess he hadn't seen Database Health Monitor, and then he and I actually chatted through private messages on Twitter for quite a bit, and I learned some stuff about what he's working on and learned that he really likes what he's seeing with Database Health Monitor. So yeah, good to connect there.
Yeah, very cool. And it's kind of interesting. I guess we were talking before we started recording here about the history of Database Health Monitor and how it kind of started from SQL Server reporting services, right? Reports. And again, I was there, right? I was kind of building my own, right, homegrown, and I came across Database Health Monitor and lots of other tools out there, right? That's one of the very nice things about the community and making those things available.
Definitely.
So, Compañero Conference coming up again in October 4th and 5th. And one of the things that kind of stood out to me was the importance of unstructured time. So, in that conference, they were so they had a mix of panels and speakers and then these vendor session type sessions, which weren't horrible, but anyway, but they were still vendor sessions.
Right.
So they were just trying to get through them, right? Kind of plow through it. And they kind of had this conference in a day and a half, a little bit more. And I didn't feel like we had enough time just to talk and kind of understand what it is. Are you being affected by this problem? Can I be able to keep the conversation going? And anyways, so I thought, again, it kind of give me some perspective on this idea of creating some structured content in the form of a session or a panel or, but then giving the unstructured time for people just to be able to talk, connect, right? Where are there similarities and for people just to be able to talk, connect, right? Where are there similarities and commonalities? What might I want to pick up with this person after the conference? What conversations do I want to, maybe talk about tomorrow or, things like that. And so I found that, again, it can have a single track conference the way we're going to do ours, that I would have enjoyed a little bit more unstructured time with some folks.
Interesting. Yeah, I think that unstructured time can be some of the, more valuable relationship building time that you have at a conference. And I think
exactly.
Going to a conference and just getting the material, really, you could do a lot of that on YouTube.
Yeah, exactly.
But going there and making those contacts with people and being able to have time to talk about what it is you're doing, or if we do when we do a session on performance tuning, to have time to talk afterwards about issues you've ran into or problems you're trying to work on, it can be incredibly valuable.
Yeah, no, I agree. So I am looking forward to our conference and putting that on, and we hope, compañeros, that you'll join us October 4th and 5th in Norfolk, Virginia. So you can take a look at compañeroconference.com, and we'll make sure we have the link on the show notes page again as well.
Yep. And now on to SQL Server in the news.
So this has been out for a couple of weeks now, but thought it was interesting. Many of you may be using Ola Hallengren's scripts. He has decided to put them out on GitHub. Kind of made them available. I mean, obviously they were always free to download, but now the difference being that you can actually suggest changes to his code. And I know that a couple of people have done that already. And so it'll be interesting to see kind of what happens with those scripts as a result.
Interesting.
Kind of going back to our community episode, we talked a little bit about this. I don't know. Yeah. So it'll be interesting to see what happens.
And, we didn't really talk much about Ola's scripts on the community. It wasn't really a community contribution project. It was just something he's built over time.
Right.
But now that it's out on GitHub, maybe it will become something more amazing than it is already based on community contribution.
I think it came out, I believe it came out on GitHub after our episode. So I wonder if we're not influencing people out there, Steve.
Who knows?
Yeah, can we take credit for that? SQL community, you can thank us, Ola, putting his stuff out on GitHub.
Whether we were the cause or not.
Yeah, that's right. Yeah. Butterfly effect or something, right?
Yep.
Okay, so today's episode can be found at sqldatapartners.com/plancache.
Or at sqldatapartners.com/103 for our episode number.
And so again, ultimately, what we're talking about is execution plans, the plan cache, and plan reuse. So first, I guess we'll back up and kind of from the 10,000 level view, what is it we talk about when we're talking about plan cache?
Well, from the high level, it's basically the plan cache is to be brief here, I guess, a piece of memory or a chunk of memory in SQL Server that keeps track of every query plan as it gets compiled. If your queries are written in a way it can reuse the plan, it can then grab and reuse one of those existing plans rather than having to recompile that every time.
Sure.
The concept behind this is it's there to make things a little bit faster by reusing cached plans.
And so allow me to go actually back up just a slight bit higher and take the idea that, we use T-SQL to tell the database what it is that we want out of the database, right? So T-SQL as the result, T-SQL has been described as that, as the language of what it is that we want, but it doesn't tell the database how to go get it, right? So the database gets to decide how best to do that. And when the query comes in, like as you mentioned, it's going to go through a process to decide, okay, well, this is what you want. How do I need to go and get that data? And so as the result, it's going to go through, look and say, okay, well, I think this is the best way, and I'm going to create a plan, right? I'm going to create an execution plan or a way to go and get this. So that way, every time you want it, I'll know how to go get it.
Yep.
And there could be many different ways, almost like kind of going, from point A to point B, lots of different ways to get there. And it has to figure out which way is the best, or at least which way it's going to use on a regular basis.
Right. And that's basically, it can be a very expensive step in the process, that compiling and figuring out how it's.
Well, and it's interesting because I always thought about, so they mentioned expensive, and I guess it kind of is, right? But there's a cap at a couple of milliseconds, which all of a sudden I can't remember how many it is, that it will decide what that is. And I always thought, well, gosh, milliseconds doesn't sound like all that long, of a time. But I think it's all a matter of how busy, right, your server is, and then how many executions are coming to SQL Server as well, right?
Yep. And I guess to put it in perspective with milliseconds there, I mean, last week I was working on a query with a client where we were trying to decrease the runtime from about 800 milliseconds down to about 150 milliseconds.
Wow.
And milliseconds can make a big difference there. And this was a query that was being run continuously, like through website traffic and web service traffic and all kinds of things. It was being hit quite often. So the difference between 150 milliseconds and performance of the system.
Sure. And that's another great point, right? Is the frequency not just of all of the queries, but of that specific query, right? Because if it had to recompile every single time and you're adding, milliseconds on there, then again, you're kind of just piling everything back up and it's got to go and redo a lot of that work every single time.
Yep. And the work that it's doing there is it's going out and it's looking at statistics and what indexes are available and what data are you looking for and what are you filtering on. And it puts all those things together to figure out what is the best way that the SQL Server engine can go and get your result set for you. And
yep.
If it wasn't so smart, it would just say, I'm going to go out and I'm going to do a full table scan on every table you're looking at and give you your results brought back together on your joins. But that just wouldn't cut it in today's world. Maybe databases 20, 30 years ago might have done that. But today, there's so much going on with indexes and might be more going on with indexes and big tables and different ways to get at the data that there's a lot of options there to look at. I mean, if you've got a table with 30 indexes on it versus a table with 2 indexes, there might be more work that has to happen there when it's figuring out what is the best plan to use.
Sure. And then we kind of get into data types, right? That plays a role as well. And so there are lots of things that it has to look at and consider.
Yep. So what happens after that plan gets compiled is it gets put into this memory location called the plan cache. Those plans are kept around with the hope, and this I think SQL Server hoping that they will be reused so it doesn't have to do that work again.
Right.
Sometimes they never get reused. What you end up with is what could be called a one-time use query plan cache. If things are changing in the query and they're not identical, you end up with all these one plan cache that can kind of clog things up and sometimes push other things out of the plan cache that would be useful to be reused. So,
right. Like you mentioned, I guess going back to that idea. So the plan cache is a space of memory, right? Where your data has to store as well. And kind of this idea SQL Server reads everything from memory, right? So it has to be able to read that stuff there. And so if you're not using it, that means that there are, memory is kind of a vital thing and a finite thing as well, that you're using those resources in a way that's not helping your SQL Server go faster.
So think of it this way. If you had, let's say we had a table called podcasts, and in there we had a list of all of the podcasts that we know about. And in there was a column called host. And you just said select star from podcast where host equals Carlos. If you run that query, it's going to create a cached plan. And then if I come along and run that same query a moment or two later, or even a few minutes later, and I run the exact same query, select from podcast where host equals Carlos, it's going to not have to recompile that. It's just going to use that already compiled plan, and it's going to save some time there. But then if we change it up and Carlos runs the query to say select from podcast where host equals Carlos, and I say select from podcast where host equals Steve, that's going to be 2 different plans because the queries are different. By different, if you just look at the text of that entire query, and if it's not exactly identical, meaning carriage returns in the same place, and I mean, everything exactly, right? Space and the layout and everything is exactly the same. And what's different is we've changed the where clause or the where filter to say Carlos or Steve. That shows up as 2 different plans in the cache. Now imagine if this was like select, instead of saying Mary or customer name equals any of the 10 million customers you have using your website, you could end up with many, many of these one-time use queries that may not, or maybe they get used once or twice or 3 times while that customer's there, but they end up chewing up a whole lot of memory. And the way you get around that is you use parameterization. The way that works is instead of saying select from podcast where host equals Carlos, you say select from podcast where host equals a parameter. And that parameter is there. And when that query gets run, whether you're running it through code you've written, website code or SQL or reporting services or wherever, instead of passing through the text string of Carlos or Steve as the parameter, it passes through a separate parameter that says compile this without knowing what the parameter is necessarily. Just compile it. And
Yeah, just for
that says compile this without knowing what the parameter is necessarily. Just compile it, and then we'll fix up that parameter after the plan's been compiled.
right. And so this then, one of the ways that it goes and then figures out what maybe parameter it should use as a default is it will look at those statistics to say, okay, well, just for sake of argument, there, I see Carlos is in here, well, whatever, 100 times. Steve is in here 10 times. I'm like, okay, I see kind of there's a tilt towards Carlos. So I'm going to assume that more people are going to query Carlos than Steve. So I'm going to make some decisions potentially based on that distribution. And This can be a good thing or it could be a bad thing.
Yep. And an example of that, think of it as if you were looking up customers by zip code. And now imagine that you're in a small town running a business, and maybe that small town has zip codes, and you're looking up, and most of your customers are local. So most of the time when you're looking up customers, you're looking them up based off of one of those 1 or 2 local zip codes. Then you get a customer that's somewhere on the other side of the country in a different zip code. It might be that 99% of all of your customers are in 1 or 2 zip codes, but then you have this 1% that are in other zip codes. What can happen with that is that the plan can assume that most of the time that's being run with something that requires more work because it has to scan through more customers based off of that zip code distribution. But then when you run it for that one, with that one zip code that doesn't match your local zip code, it could get to that customer with less work, but it doesn't because it goes through the normal path of that precompiled plan to find the information there. There's a term for that, and it's called parameter sniffing. When a plan gets compiled, the first time it gets compiled, it looks at what are the parameters work for those parameters.
That's right. Based on everything that I know, right, as of the data that's in all these tables, what is the highest probability of what's going to come in and let me make it easiest for, kind of the 80-20 rule, if you will, right? Yep. That's kind of, that's where I'm going to go and try to get that.
Yep. So then let's say you have that customer example with the zip code and you're looking it up by zip code. And the very first time or when the plan gets compiled, you use one of these oddball zip codes that's not a very common zip code in your system. It may then look at it and say, okay, there's only a very small percentage of the rows in our result set that use that zip code. So what we're going to do is we're going to go do an index seek right to that zip code location.
Right.
But then
an anomaly in that sense. Like, oh, well, all the data must be kind of an anomaly.
Yes. But then if it was the first time you compiled that plan and it was with one of the common zip, if it was the first time you compiled that plan and it was with one of the common zip codes, it may look at that and in an example, instead of doing a seek, which would go right much quicker to where you're going for the smaller set of data, it may say, well, a majority of the rows in this table are in this zip code. So instead of doing an index seek, we may do an index scan or even a table scan, because that's going to be the most optimal way to bring back everything that you're looking for based off of that initial parameter. So what you end up with is that when that plan gets compiled, and that's compiled the first time you run it, or if it gets pushed out of memory, or if somebody flags it to be recompiled, that next time it's run, it gets recompiled. But if that time that it gets recompiled, if you've got good parameters that represent a regular data set in your system, you get really good performance out of your query. But then if it happens to get recompiled with one of those unusual parameters that causes you bogging down the system or really hurting the overall performance.
Sure. And what gets a little bit weird, and you may think, I guess, hey, well, why would this affect me, right? This should be a problem. If you've ever seen scenarios where one time a query runs pretty fast and then all of a sudden it doesn't, and then maybe later in the afternoon it runs again fast, right? That's a common symptom, if you will.
And I guess with that, the common scenario that I see as a freelance consultant, as Carlos and I are, I see that you'll be working with a client and they'll come and they'll say, things have really slowed down. We haven't changed anything on the database, and something has really slowed down on this one specific process or job or whatever it is that's calling in to use this query. And then you'll go and look at it and you'll find here's the stored procedure that's the root cause of the problem. You'll copy it out. You'll copy and paste it and put it into your copy and paste it and look at it. And you'll find here's the stored procedure that's the root cause of the problem. You'll copy it out. You'll copy and paste it and put it into your management studio and change it around so you can run it maybe not as a stored procedure, but in line. And you run it and everything runs great.
Yeah.
Because with the changes you've made to be able to run that in line, it gets a different plan.
Yes, new plan. Yep.
And then you look and you think and you look at weight statistics or something like that, and you can see that at like noon today, that's when things just tipped and it went bad. And prior to that, everything was running great. So what could have happened to cause that, and what often happens, is that you have a stored procedure that gets pushed out of the plan cache for some reason. The next time it's run with one of these unusual parameter sets, which causes it to get a bad plan. And then every other call into that starts using that bad plan, or it was a good plan for that one parameter, but it's a bad plan for the other parameters.
For everybody else, right?
Yeah. And I hear that and they gripe and say, oh, the database is horrible and everything's broken.
That's right.
But this is really all because of the parameter sniffing. And parameter sniffing is a good thing because without it, SQL Server wouldn't be able to optimize your plan for any kind of parameter.
Sure.
But occasionally it goes wrong and you end up with the wrong plan based off of plan reuse on that stored procedure.
And you may be thinking, right, like, well, again, how big of a problem could this be, right? Now, I won't say it's the only reason, but the new feature, the query store feature, is basically trying to solve this very problem, right? And so it's big enough of an issue, of a problem, that Microsoft has built a tool to help you combat it.
Yep.
Right. And so I think it's one of those things that I think a lot of, particularly when I can remember going back and being frustrated. And I think a lot of, particularly when I can remember going back and being frustrated. And I think a lot of times it probably had to do with parameter.
Yep. And most of the time when I run into parameter sniffing issues, it starts with customer service department who's working with customers, getting lots and lots of complaints that something's gone wrong or that the system's down or not responsive.
Sure.
And then it leads to then eventually jumping into the database and finding, okay, here's the problem. There's a lot of different things you can do to help mitigate the issue at that point. I mean, one of them is that people will put the option recompile on a query or the recompile hints on a stored procedure. And that can cause more problems or different problems.
Well, let's explain that. Let's just go through that just for a little bit, right? So now what we're saying is, so to mitigate that, you can tell as it goes through the process of actually creating the plan, there's some called hints, right? Or I guess a stronger word is plan guide, but that's slightly different.
Right.
And we'll touch that in a minute. But you can tell SQL Server, hey, SQL Server, you should do it my way. Right. Or in the example of the recompile, you're saying, hey, I want you to, every time you run this, I want you to recompile. I don't want you to use the plan you have available to you. I want you to throw that plan away every time and figure out how to do it again.
Yep.
Right. And so that's an option that you have. Right. But there are risks, if you will, associated with that. And you want to be careful about how you go about, or when you go about implementing that option.
And one of the knee-jerk reactions that I often see when I explain to people that, well, here's what happened. You had a parameter sniffing issue, the query got a bad plan, or the stored procedure got a bad plan. Here's what we did to fix it. We forced it to recompile, or we changed the query around. They often think, we'll have this issue again.
Yeah, exactly. How do I eliminate the problem, right, from ever happening again?
Yep. And then the answer to that is, well, you could. However, by doing that, you would eliminate any of the benefit that you get from the plan cache and being able to reuse plans.
Yeah, exactly.
And depending on the system and the performance there, that could make things far worse over time, depending on the load. So there's things you can do. You can go in and perhaps change the queries or change how things are working in the stored procedure, or maybe have a stored procedure that calls another stored procedure that does something different. I mean, there's probably 20 different ways you could go to figure out how to.
No, yeah, exactly. That's right.
But I guess we don't have time to go through all of those now, but the knee-jerk reaction is just make it so that everyone recompiles, and that's not a good thing to do.
Right. Well, at least by default, right? I mean, that may be an option that you pursue, but don't make that your first choice. Two, but don't make that your first choice.
Oh yeah, and I've certainly used that for a single stored procedure or a couple of problematic stored procedures. Use the recompile option on them, and every time they run, they get recompiled.
Right.
And it's just
That's the
because of how they're written, and they're in positions where they could be rewritten, but the overhead of recompiling those is cheaper than the time it would take to go rewrite those.
Right. But I think it kind of comes down again to kind of knowing your system and understanding so you understand the problem. You understand, okay, I believe I have a parameter sniffing issue. What do I know about this either query, procedure, view, whatever it is? And do I know any history about it? Can I go find some of that out to then understand what makes the most sense?
Yep.
Right?
Yep. And we could probably go for hours on parameter.
Sure.
Now, so one of the things that often comes up with the plan cache is people will say, well, how do I control the size of the plan cache? And
can't.
You can't. It's something that's dynamically sized by the SQL Server internally, and it depends a lot on the server load and what memory is available. I mean, one way to control it is just put more memory on the server, but that's not a really good answer.
Right. Well, another feature that they added, I guess on all of a sudden I'm forgetting the addition. I want to say was it 2014? It seems like it was older than 2016, but maybe I'm remembering wrong. And that is when they added the ability to add Flash. Like, so if you had Flash on the SQL Server, you could actually expand the plan cache to use that Flash array to give you more space, right? When you had an issue like this. So again, so to kind of indicate the gravity of the problem, right? Microsoft, when you had an issue like this. So again, so to kind of indicate the gravity of the problem, right? Microsoft is putting solutions out there around the plan cache and its size, even if they're not giving you the controls of like an Oracle to say this is what it should be, because
right. So the best way I've found to deal with the plan cache, if you've got stuff that's getting pushed out or a lot of one-time use queries in there and things like that, is to better understand what's in there. And then it might be, and I've worked on systems that have tens of thousands of different queries run against them. And then it turns out there's a dozen queries that are really the big offenders in the hogging up the plan cache with one-time use queries. And you can go in and work and optimize those dozen queries to use parameters or to do whatever needs to be done there. And oftentimes with a small amount of work, you can have a really big impact on the plan cache there.
Right. Right word for optimize for ad hoc workloads comes in, right? So this idea of this ad hoc is that, hey, I have a one-time use or a one-time run query, but I have a whole bunch of those. What I'm going to do is, instead of capturing or keeping the full-blown cache execution plan, rather, is I'm going to just keep a little stub the first time it gets run. And then when you get run a second time, then I'll keep the whole thing and, make use of the, being able to run it more frequently.
Yep. And that optimize for ad hoc workloads is one of those parameters that we most of the time will recommend people turn on.
Yeah. I know we've talked about it before. I've only ever heard of one person complaining about it, which we actually talked about. What was an episode like 99? Mindy had brought it up. We were in the panel in Baltimore, and I remember Wayne Sheffield talking that he had seen some CPU spike. But I think, and again, so you have to test in your environment, right? Because it's bend, but it seems like it's almost one of those standard features you can enable now.
Yep. And that's why I said we almost always recommend it. We don't always, but almost always.
Right.
Yep. So then I guess, as far as understanding what's going on with your plan cache, and I know we talked about Database Health Monitor a little bit earlier, but in the very beginning, when I first created Database Health Monitor, some of the very first reports that I built were around understanding the plan cache, because I was working in an environment where it wasn't well understood, and I needed a way to be able to show what's going on with the plan cache.
Sure. And I think, at least from my first interactions with that, are giving me the top queries, right? Because it will keep some statistics about the plans and their executions. You can go in and start to interrogate that a little bit.
Yep.
And so generally, at least from a bit.
Yep.
And so generally, at least from a performance perspective, that was the first time I remember kind of going in and taking a look. It's like, well, what are the top plans by CPU or by memory or by, just how long it ran, something like that.
Yep. And there's 4 reports in there that I usually look at that are right around understanding the plan cache. And one of them is just called the plan cache report, and it's a per database report. And what it'll do is it'll show you the first 500 largest plans in the plan cache. And it'll show you how big they are. So you can go and see, oh, wow, we've got 12 plans that are very similar that are taking up 30K each.
Sure.
And you do the math and you add it all up and realize, wow, some of these add up real quick to taking up a lot of your cache. Another one that's really handy is the needs parameters report. And what it does, it goes through and it analyzes the queries that are in the plan cache, and it looks for things that could be parameterized. And then it groups all of those together. So if you had 1,000 queries with, let's say, customer name in them that was hard-coded in the query, it would go through and say that by fixing this one query, it would reduce your plan cache from 1,000 instances of that same or similar plan to be one reusable instance.
Now, let me ask you a question on that, because I guess this is where maybe I'm drawing a blank here. There's a gap, right?
Yep.
Because I thought that even so we talk a lot about stored procedures, right, versus ad hoc, so views or just inline queries.
Yep.
And so, but I thought even though I was an inline query and I've been written with like entity framework or something, right? That if the SQL Server gets that query, it's still going to try to parameterize it, right? It's going to, even though it's not a stored procedure, I guess is what I'm saying. Obviously vary the reasons why I would have that. But in that scenario, what do you then go?
We were querying the podcast table, select from podcast where host equals Carlos or host equals Steve. If you're running that code and it's actually running that exact query hard-coded from whatever application it is,
right,
but that's what's ending up in the plan, it's hard-coded with Carlos or Steve in there, that is taking up, just for those 2 queries, 2 or sometimes 4 plan cache entries. And let me just clarify that. When I say it's 2, that's the obvious. 1 for the query that's looking for Carlos, 1 for the one that's looking for Steve. But sometimes you will get a parallel and a non-parallel version of that query in there.
Right.
So sometimes a single query will have 2 different plans in the cache. But to go back to what you're looking for there, if the application is passing through hard-coded strings like that, each one that it's passing through will get a different plan. So then that's really all that the one-time use queries, the needs parameters report does, is it goes and finds the items in the plan, finds the items in the plan cache that are very similar with everything besides the parameters.
So I guess let me ask the question, this way then. So
I don't think I answered that, did I?
Well, no, I think you did answer it. I think I asked the question wrong. And that is, so I am misunderstanding, and SQL Server will not in every instance try to parameterize your ad hoc, I'm going to say ad hoc queries.
Yes, that is correct. And the way to tell that is to look at what's in the plan cache. And if what's in the plan cache contains those hard-coded values for a name, for instance, then they haven't been parameterized.
Okay.
Or the other way to look at it is if you run it with 2 different names in that value, do you get 2 copies of that in your plan cache?
Right.
And if it is, then it's not parameterizing it.
Yeah.
So.
Okay.
I guess the thing I like to do is find the ones that are the most commonly ones that need big impact. This only works if you have access to the code. Because if you're running an off-the-shelf application where you can't change any of the code, you might not be able to do this. But if you're a development organization, you're building an application, if you can go in and find that these are the queries that end up using the most out of the plan cache, they have big plans and they're called thousands of times, and then you can figure out which ones need parameterization and go parameterize a couple of those, you can oftentimes have a big impact on the amount of those one-time or low-use plans that are in the cache.
Right. And so I guess again, to connect the dots here, right? This is where we're actually going to the code, and instead of using that hard coding, you're going to use the SP execute, or, you're going to changing the way that you're making that call to the database. Right.
And I mean, for instance, if you're working in pretty much any programming language that I've ever seen or worked with that allows for parameterization, you usually pass through some kind of a parameter value like a variable name in place of where you would be filtering on that hard-coded string.
Gotcha.
And then in the code, you say, here's the query, patch it up with these parameters, and then execute it.
Right. The developers have to make one more step, right, in putting that dynamic, what I'm assuming is a dynamic query, and just kind of, linking it all together.
Right.
Before they send it to the database, they need to make one more step to help us out a bit, right?
Yep. And then we could have a whole nother conversation for probably an hour on parameterization and the impacts that it has on SQL injection, or on preventing SQL injection, or helping prevent SQL injection.
No, yeah, exactly.
But there's other benefits to parameterization just besides the performance, and maybe we'll save that for another time.
Yeah, makes sense. Makes sense.
So there's a couple others that I look at is one-time use queries report. Did I already mention that one?
Yeah, I think we may have touched on it. I know we talked about it, but this is
monitor that I really like.
Show us how many queries have just been executed one time.
Yep. And that's a handy way to see how many of these are there. And if you look at your database and there's 2 or 3 or a couple dozen, you probably don't have to worry about it. But if you find out that there's thousands of them there, then maybe it's something you need to look into.
Right. And then that's where that optimized for ad hoc workloads comes
in.
That's the change there.
And then the last or the other report in Database Health Monitor that I really like to use to understand this is the instance level memory report, where you can go in and see how much memory is being used by each database, but it also shows you how much memory is being used by the plan cache. And it's interesting. On some servers, the plan cache might be using more memory than some of your databases are. And on others,
really?
It depends on the size of your database and performance and things.
I guess that's true.
And the load. But it's just good to understand how big it is. And I guess I said earlier, you can't really control the size of it, but you can control the size of it by reducing the amount of one-time use queries, either through optimize for ad hoc workloads or by adding
influencing,
parameters.
Right?
Yes,
influencing what's in there.
Yep.
Right. So another thing, I guess that we will touch on. We talked about it earlier. So we talked about the ability to manipulate a little bit of this, right? So through using hints, recompiling. And the other one is plan guides, right? We also want to say, right, that, again, take it for what it's worth, right? So, but in my years as a database administrator, I've only seen hints and guides used in 2 instances. I think sometimes, particularly on the forms, we kind of see that they kind of get rushed. It's kind of again, kind of this idea of, well, I want to make sure it never happens again, right? So I'm going to kind of put this very extreme process in place when, again, maybe, testing it out a little bit would be a better approach.
Yep. And I think in my experience, I've seen that hints are used quite often, are used very infrequently. And I just want to take a second to jump back to a previous podcast where I talked about one of my things I would change around SQL Server, I think, was on the terms hints and plan guides.
Yes.
And that hints aren't really hints, they're really commands.
Right.
And plan guides aren't really guides, they're commands that say you will perform this way.
Yeah, exactly.
Yeah. So I think that I look at hints and plan guides. Oftentimes, the first thing I'll do in performance tuning is pull the hint out and see how it performs without it. And oftentimes things improve. But I think that they're kind of a emergency Band-Aid type response. When you're out of other options, it may be something to consider as a short-term solution.
Sure. And I guess, and I don't mean to say that they're not, that they shouldn't be used, right? I mean, when they're appropriate, right? But I think, again, kind of like that whole rebooting of the server, right? Like, oh, it's slow, let's reboot it, right? Kind of a stepping away from the knee-jerk reaction.
Yep.
They're away from the knee-jerk reaction.
Yep.
There are going to be instances where they are called for and where you're going to be the hero, right, for implementing them.
And I think plan guides are amazing. They're extremely awesome, but they're extremely dangerous. And I don't want anyone to think of this podcast and what we're talking about here as a recommendation to say, go try out plan guides for your performance tuning. If you're hearing that, you should translate to go learn all you can about plan guides before you ever try it, because there's some negatives in there.
Sure.
If you apply a plan guide, it may cause trouble when you try and recompile a stored procedure that's plan guide is associated with.
Right. And again, kind of going back to Query Store, that's the flip side of the other angle it's going to help you understand is, hey, this query is running with a plan guide or a hint.
Yep.
Right. And give a little bit better insight into, because it has been difficult. I mean, it's something you have to really spends a lot of time with, at least, again, the knuckle dragging,
Get compiled at the
understand, okay, what's going on here? How are these plans changing over time? And it does take some practice, and just you'll get a little bit of frustrated, but hang in there, and eventually it'll come.
Yep. So I think just kind of a quick recap then overall. So basically, the SQL Server plan cache is where all the cached, where all the compiled query plans are stored. They get compiled at the first time they're used, or when someone indicates that it needs to be recompiled. It's kind of sized dynamically by SQL Server. You don't really have a lot of control over that. And there's some things you can do to adjust that, like optimize for ad hoc workloads and parameterization. And I think hints and plan guides can oftentimes cause trouble, but they're kind of a last-ditch attempt to try and fix queries.
Sure. Okay. So again, ultimately, we'd like your feedback on this. And one of the areas, and kind of talking or reviewing this topic again, is we would try to make Database Health Monitor better. And so we're soliciting your feedback, right? We'd love for you to take a peek at those reports. We'll make sure that we put them on the show notes page and list them there. But we'd like to get some feedback. So as you use them, what do you like about them? What else maybe do you want to see? How do you use them? Is there some other tool that you're using to kind of take a look at the plan cache? We'd be interested in hearing from you about that. And you can use any of the options of social media to leave us a comment or a thought there.
Or you can leave a comment on the podcast show notes page as well.
That's right. So our episode URL for today is sqldatapartners.com/plancache. Our music for SQL Server in the News is by Mansardian, used under Creative Commons. Again, thanks again for tuning in to this episode. If you want to connect with us on LinkedIn, I am at Carlos L. Chacon.
Or you can find me on LinkedIn at Steve Stedman. We'll see you on the SQL Trail.
SQL Data Partners.